Um, Hi. So today I'm joined by Nikko. Hi, Nikko.
Hi, David.
And Nikko's recently completed a master's in management at St Andrews University. Well, congratulations.
Thank you.
And prior to that, Nikko last year completed a master's in physics,
Mhm.
also at St Andrews. Um, So, Nico, thanks for taking the time for kind of sharing a bit from your experiences. It would be great to hear a bit of an overview about, briefly about some of your journey so far. For example, what A levels you did, and what you subsequently decided to do. A bit of an idea about what attracted you to decide to actually do
Mhm.
your degree in physics as well.
Yeah. So for me, I think I would like to kind of start a little bit earlier. Growing up upwards to like middle school, I was not a student at all. I actually really did not enjoy any of my classes, like the science, the math. It was, I'm from Thailand. It was a very much like a high pressure environment to do well, and I was very much middle of the pack. Didn't really have any passion really until I discovered astronomy. That would have been to convert to the UK grade system would be like year 7, year 8 was when I discovered astronomy. And then I started looking into it, going like, ooh, I want a career in astronomy. What do I have to study? And I go, okay, I have to do physics. And then what do I need to do? Physics, math. And I realized, okay, I have to kind of start working on my math. So for my IGCSE, I did all three sciences, so physics, chemistry, biology. I wasn't good enough to do further math, so I was in the middle, just normal math. I did drama and history, so I think that was my six. I think there was Thai and a couple of other things, which is quite no longer relevant. That then led me on to do physics, math, further math, chemistry, and an EPQ with Edexcel for my A levels. Um, and that choice was pretty much purely to apply to university. I was considering doing history instead of chemistry, but my history teacher said I can learn history whatever in my life, but not chemistry. So that was pretty much the only decision I had to make. Yeah, and then yeah, from that point on, since I realized when astronomy, I was pretty much set to do that ever since. Yeah.
Cool. Um, yeah, that sounds like good advice to be honest about the chemistry front because
Yeah.
especially the labs aspects of things, it can be quite difficult to.
Mhm.
I mean, there's a lot of chemistry you can learn independently, but the lab side of it, and just that general,
Yeah.
um, yeah, the temperament as well. Doing labs is something that is kind of it is partly a social kind of. Okay,
Mhm.
I've kind of because I did a degree in chemistry, I got a bit
Okay.
but no, yeah, I get yeah, it was good advice anyway. Um, cool. Yeah, okay, so you say as far as the degree or like the doing the physics is something that
Mhm.
actually for quite a period of time you're quite interested in doing that.
Yes, it was the astrophysics aspect of it. So when I was looking at university and looking at different courses, I very much picked university with a dedicated astrophysics course. So my degree class title was MPhys in astrophysics, whereas in St. Andrews you can graduate with just physics. So that's what we colloquially call the experimental physics, and then theoretical physics. So for me, it was the astronomy part that drew me in.
Right. And what's some of what perhaps got you interested in the astronomy part?
I think it's the beauty of it. Like I really cannot emphasize how much of like a student that did not care about stuff inside the classroom. Like I mean, education in Thailand, at least back in my days, was very much from the textbook, from a centralized curriculum. There's just memorization. There's no exploration. And then one day, it was because I saw the Milky Way for the first time. And I was just completely in awe by how beautiful it was, and um, it's a feeling that made me realize how small I am, how insignificant I am on the grand scheme of things. And I think it's this beauty that led into this passion for the field that really dragged me in.
Interesting. Interesting. Um, and once you started your degree, would you say um, there's things that going in you perhaps didn't quite know about as far as your expectations, which changed once you actually started the course, and yeah.
Um, are we talking about like the content of the course or just my experience in general?
Both basically. I guess
Okay.
both. Yeah.
I guess the first thing that I want to bring up that comes to my mind is probably the opportunity. And I am talking about this from an international student perspective. Um, I would say that the opportunity is kind of unequal. A lot of the times when it comes to funding, to do summer research, or in my case, like to pursue a PhD, there is significantly less. And then there are also constraints when it comes to what I have access to as an international student regarding certain courses or I think career in certain fields like defense or aerospace. That is a lot much more harder to get into than I anticipated. This also, another good example for me was teaching. A teaching career was something that I was really, really interested in getting into. And I tried to apply to the Ogden Trust kind of teaching scheme for physics student. And then I was declined simply on the basis that I won't be able to stay in the UK to work as a teacher because it wouldn't pay enough. So that was something that I completely did not expect that I would go into. And if I was honest, not something that I thought about or anyone has ever told me about while I was kind of on this journey to come to do this degree. Yeah.
Interesting. Yeah. So I guess from an international student perspective, I can imagine there's a number of things which um, yeah, I've seen those um, I've seen some cases online where it's things to do with like sponsorship and stuff. They got these internship opportunities, and then they were like, "Oh, actually, we're not going to sponsor." Yeah, yeah, yeah. Um, um, Now, despite some of these obstacles, you were able to secure some research experience,
Mhm.
like internships, like research internships alongside your
Yeah.
degree. Um, what were some of the things that, as far as the subject focus, and then also what were some of the um, things you learned from that? Like, what was, I guess you could kind of go into what that experience was like.
Yeah, I would say it's very different from studying at university. I was extremely grateful that I landed a very good research opportunity in my second year summer, mainly because first year summer was COVID, so I was a COVID undergrad. So I didn't get to do much in my first summer. But yeah, in the second summer, I found this fantastic supervisor who I continued to work with for pretty much the rest of my degree. My dissertation was also with him. Um, and yeah, it was the experience of doing research um, that I think was really, really helpful for me to decide to continue doing higher education towards PhD. Yeah.
Yeah, so what were some of the actual so what were some of the things you actually researched? What was the
Yeah.
project process like?
Mhm.
Um, and you mentioned, it differed from, some of the traditional, I guess, the not regular academic stuff. Um, in what were some of the ways in which you found it differed? Yeah.
Yeah. Okay. So I'll just kind of go through the process of how I landed it then. So I knew quite early on that I was interested in transient astronomy. And that was a field that here in St. Andrews, um, there's not much of a big focus on. There are some member staff here who are interested. So I think around quite early on in this like semester one, I started going through the directory of the school, start reading through each of the research staff interest area in research. Then I found my supervisor profile probably in October. I sent him an email. He responded back in like a week or so saying that we could meet up. I went to his office and then he just listed out some of the ongoing research he has. Then I basically picked a project, and then the next question was funding, how to get the funding. So from that point on, we start exploring some options. So um, the university usually has internal, for the school specifically, the physics and astronomy school, has internal funding for student research. But then there's also the Royal Astronomical Society, and then there was a scholarship called the Laidlaw Research and Leadership Scholarship, which I ultimately applied for, and then that was the thing that gave me the grant to do the research that summer, and also go to Boston to do to lead a coding course for students in a low income area in Boston. But yes, come back to the research. So that summer I worked on identifying active galactic nuclei for an upcoming space telescope mission. So that was a lot of data mining, just cross matching catalogs and trying to identify active galactic nuclei in the northern celestial cap, which is a region of the sky which previously was very limitedly observed because it's near the pole, and that's not where most of the telescopes are capable, or not capable, but the air mass is so large that it's not good data quality from there. So with that project, I learned how to do a lot of data handling. I did a lot of going through the literature, which I think for a second year student at that point we barely touched upon. I think we only read 2 or 3 assigned paper in our classes. So that was like a really enlightening moment to see, okay, this is the kind of day-to-day process that you do while doing research. And then another kind of useful thing that I learned was about like project management, because I was very much in charge of the direction of the project. My supervisor was pretty much there to help guide me in the technical aspect, or like pointing me to the correct tools, but kind of setting the goal, setting the complete the task. These was very much like my own responsibility, and I think that really built a pretty good foundation for me moving both during study time when we have to do like massive coursework that takes like a couple of weeks onto my dissertation. And I find myself kind of having these little habits of like writing under little goals, being what's the word, being reasonable with my expectations and all of that, and seeing what is feasible. I find that, yeah, I've learned that from my first research experience, and that really helped me along pretty well. Yeah. Did I answer all your question there?
Um, I mean, yeah. I mean, yeah. Yeah,
Okay.
basically,
Yeah, yeah.
yeah, of course, yeah. Um, so this is more of a science question because I'm,
Mm.
obviously, astronomy is not my kind of,
Yeah.
you know. What is active
Active galactic.
active
Yeah.
galactic nuclei?
Yes. So every single galaxy has a supermassive black hole in the center, right? So if you watch, I mean, Interstellar, like the gargantuan black hole, or a couple of years ago, the Event Horizon took the picture of the Sagittarius A star. Um, that is like the supermassive black hole at the center that kind of hold that. Yeah, it's there at the center. Now, when object accretes onto the black hole, it usually forms a disk due to the conservation of angular momentum, and this disk then um, releases a lot of energy. It's actually one of the most efficient process in the universe, and the light that is produced from this disk actually outshines the entire galaxy itself. So, because of that, we can then deduce like the geometry around the black hole, which then leads to us being able to calculate the mass of the supermassive black hole. And then that would then tell us about the different properties of the galaxy.
So essentially, the active ones have a black hole in the middle. Is that what you're saying?
Oh no, the active one has an active one will have a disk, an accretion disk around the black hole.
Oh,
Yeah,
okay,
yeah.
okay,
So pretty much, oh, I want to make sure that I get this right. I feel like any galaxy can be an active galaxy at, once there's matter that accretes onto the black hole in the center that causes to form this really, really bright disk.
right, right. Okay, cool. Um, yeah. So you did a number of like summer research.
Mhm.
You did the initial one. You did a number of one afterwards. Um, and I guess going into the some of the subsequent ones, I mean, I guess it'd be reasonable to assume you probably had slightly stronger, stronger research skills going into some of the subsequent ones. With that perspective in mind, what are some of the common mistakes you've observed that students who are quite new to this kind of research, what are some of the mistakes that you've observed?
Mhm. I would say it's the expectation. Um, I think some I mean, myself included, right? They start a research project thinking that they're going to achieve A, B, C, D, E, F, but then in reality, given the time available and the complexity of the project, you might only be able to do A. And I think um, because of that mindset that you want to achieve everything you set off to do, sometimes you miss out on like key like learning moments, or like you miss out on the ability to appreciate the work that you have already done, and that kind of leads to you not be able to do the part that you're able to do to the best of your ability. I would say that's probably the most common issue that I've seen, um, with myself and also a lot of my classmates who we kind of gone and did summer projects together.
Um, have you observed cases where students were maybe too focused on literature as opposed to actually getting into the
Ooh,
more practical stuff?
I'd say not in physics. Um, yeah, I can't say I've seen that during the summer research period. But like during my dissertation, like when all of us went through dissertation together, I say, yeah, some people could have been a bit more like bogged down on the literature. Um, but I think that's where like your supervisor comes in and then they go, actually, this part is not relevant, or like, you need to start your work now. And I think that kind of helps. Um, it helps a lot for people who are stuck on the literature.
Right, right, cool. Um, one of the things you did during your time at university, and you did this for over a number of years, you did quite a
Mhm.
number of quite involved like leadership related
Yeah.
activities. I believe it was the Astronomical Society.
Yes. Yeah.
Um, how did you initially get involved in the society, and then what was some of the yeah, what was that? You can kind of
I think it's best to describe myself as like a keen bean. I so when I joined university, there were two opportunities which I wasn't really sure what the difference was. There was one which was the astrophysics class rep, and then there was the freshers rep for the Astronomical Society. Um, and yeah, I just decided to apply to it. Um, the motivation behind that really was because I didn't, at least back home while I was going through school, there basically wasn't that many people who was interested in astronomy, or at least not anyone in my year, that's for sure. So I was very, very keen to meet like-minded people. And I did have leadership opportunities throughout school as well. So I think that kind of, it was an easy decision that like, yeah, I'll just continue doing these representative roles. Yeah, and it was very well advertised when I joined, or at least within the class rep one, it was very well advertised by the staff in charge of the year and the induction and what the roles entail. Um, with the Astronomical Society, I think I was less sure. I knew it was like a student, society that appreciated astronomy, but it turned out to be a really good community in there. And then I stick around for pretty much the remaining years of my time. So I was then event coordinator, then the deputy observing director, then one of the observing directors, then president, and then I helped out organize the student ball in my last year for my first degree. Yeah.
Um, yeah, and, I mean, what I observe is you got this of course you started as freshers rep, and then eventually you became the president of the society.
Mhm.
How did things I mean, it's quite a different perspective, right? Being an active kind of team member versus being kind of the leader of the society. What was that? Yeah, that kind of change in role. What was that like for you? What were some
Mhm.
of the challenges as well? Yeah.
Yeah, I think it's how you behave. There are certain expectation, and this idea that I'm still kind of wrapping my head around is that people look up to you, and so you have to kind of set a good example. Um, I guess like one big thing, or yeah, I might be a bit vague about this, but I think, yeah, I'll try not to overshare the details. But let's say if there are any issues in the society or like within the committee, whilst you're part of the kind of the ordinary, so usually in student society, at least here in St. Andrews, there's like the I think it's called the executive team, and then there's the ordinary team. So the executive team is, president, vice president, treasurer, secretary. When you're part of the ordinary team, you can kind of openly discuss things with other people about what happened or your opinion on things. But then once you're in the executive team, then there's procedures and there's ways you handle things. You can't pick a side, or like you can't voice about your opinions on that thing. And I think that was probably the most difficult things for me to learn and act in my position during that time. Yeah.
Right. Right. Cool. Um, yeah. So um, I'm quite curious. Some of the some of the subsequent research you did, you mentioned quite a bit of it was with the. You say it was the same supervisor,
Yeah, yes. Yeah.
um, which is quite interesting. Like sometimes students will do, they'll do their summer research with one supervisor. They'll do their some of the subsequent research with a different supervisor,
Yeah.
which each can have their pros and cons. But from the general gist I'm getting from you is that actually was very good supervisor experience for you.
Yeah. So yeah, I think I'll add a little bit on that. So like I said, not many staff in St. Andrews here does transient astronomy. And so the supervisor I work with, I think yeah, his main research is in transients. Now, occasionally, especially when I was applying to like research, like not research camps, but like summer schools or like research, it's like summer research opportunity at other university. Sometimes I did feel like I was at a disadvantage because I was solely relying on the same supervisory references. So I say, yeah, I think if I had gone back in time and then had the same opportunity, I think I would have picked diversify my opportunity a little bit. But in terms of the research and opportunity, and I mean, he is an amazing supervisor, and so just on that, and then our kind of aligning research interest alone, I was very happy to keep working with him. Um, I think just to clarify a little bit as well, I work with him. There's this module called Transferable Skills for Physicists here in St. Andrews, where as part of it you do like an independent research and you write a literature review. So I also picked him as my supervisor, and then as well for my dissertation supervisor. But then the subsequent summers, I ended up working with other member staff as well. Yeah.
Cool. Cool. And I guess briefly, transient astronomy. What is that?
Okay, so transients mean things that are like moving and changing, right? Um, so I think like for most of human history, astronomy has been a very static field, apart from if you're observing the moon, the sun, the planets, and then the rare supernova. Otherwise, we know exactly where everything is. Nowadays, we have the technology to observe things that are changing on days, hours, seconds, and milliseconds. And so with this much higher temporal resolution, we can actually study what's changing, at a short time scale. And so, this allows us to study how planets are forming by observing disk around star forming region and looking for like changes in brightness. Or another example that might be more common now is like exoplanet hunting, right? Where we're just staring at the star until we see a planet pass by, and then we see that through the dip in the brightness. So yeah, that's kind of what transient astronomy entails.
Cool. Cool. Um, so after you completed your undergraduate, you
Mhm.
decided to um, you decided actually you wanted to pursue a PhD, which you are soon to start, if I'm not mistaken.
Mhm. Yeah, so I mean, I knew quite early on that I wanted to do a PhD. I think yeah, even at school in high school, I knew that the PhD was the end goal in terms of where what I want to achieve before I start my career. Then at university, it was always at the back of my head. And yeah, my experience in my first research kind of made yeah, it validated that I wanted to do that. And then it was on the back burner during the middle period of the degree because it was much tougher. But yeah, once I start my final year, I just start applying to PhD. Yeah.
Cool. Cool. In terms of, so you said you spent time in Boston. You said part of it
Yeah.
involved coding. Was it coding?
Yes. So I was working with this NGO called the Timothy Smith Network, and
What?
their
Sorry.
goal, Timothy Smith Network, TSN. Yeah. And their goal is to bridge the digital divide in communities with less resources, basically. So um, they run a summer program where kids sign up, and the kids are actually being funded throughout the entire period to learn digital skills. Specifically, I was leading the coding and microcontroller component of this program, which focus on food security. So the idea was that we want to teach the kids both like agricultural skill as well as technical skills, and how they can combine these two to come up with devices that would help them grow food at home, for example. Um, so this was part of the Laidlaw program where they would send scholars from different university to these different NGOs around the world to do philanthropic work. And because of my kind of family involvement in agriculture, I picked this program, and they were looking for coders, microcontrollers, 3D modeler, and 3D printer. Um, I picked the coding and microcontroller because I had experience in that, and then a colleague of mine from Durham picked the 3D modeling and 3D printing. And so we both then ran these kind of part of the course together. Yeah.
Um, so when the course was being ran, and I guess the students were kind of being guided through, I'm assuming quite a number of them didn't have too much prior coding
Yeah. So
experience.
the age gap was, I think, from like 10 to 18. And so it was a massive gap. And then I think a, a lot of the student had never coded before or touched like a microcontroller before. So yeah.
What was it like trying to design, or I guess also the implementation of something which needed in some way, shape, or form to be useful for people who were such, because you can imagine that's a lot of different
Yeah.
in terms of formal like school grades. It's a
Yeah.
lot of it's a very broad range.
Yeah, so with this, I actually relied on my experience quite a lot. So I was very fortunate to had gone to like a coding camp. It was funded by the UKRI or the UK government to kind of help upskill partnering countries in kind of lower development countries. And so I was very fortunate to be selected for one of those back in Thailand. So I knew a decent amount of coding. I wouldn't say a lot, but like I understand function, I understand different data types. Coming to university, which gave me a massive heads up. But then I then went through the coding courses here. Um, so a lot of my classmates also did not know coding, and then I went through the intro coding courses, and then I kind of see that right the stuff that they're teaching is good. Like, I mean, it lays things out very well. But then if you don't understand what's going on, it means absolutely nothing to you. So what I did was I adapted the resources which I was given at university and then added more example, a more kind of intuitive and more opportunity for students to play around to really understand what is really going on. And so I think that was really my focus, is to make sure that the students are able to use what we teach them, and not just know how to print hello world or make a function that they can't apply or replicate in the future.
Okay. Um, so for let's say there's for students who are they're doing some sort of like maybe they're doing some science A levels, maybe they're doing A level in physics, for example,
Yeah.
and they're a bit curious about astronomy. They're not quite sure how to really explore or deepen that interest at that stage of the
Mhm.
maybe the kind of resources they have as an A level student, not quite
Yeah.
yet in a university context. Is
Mhm.
there any pointers you would give to those students as far as, these are some things you should potentially consider looking into or exploring to deepen that interest?
I say contact your local astronomy club. I mean, and or university, like student society, for example. At least from my experience, people are very, very keen to share their passion, and they'll very much, teach you and then let you use telescope and really give you like a sense of community to be around. I think that is definitely my first advice to get into. Other than that, I mean, there are so many online resources nowadays. Uh, I know that like NASA has a really good like public outreach website with all the information. It does involve kind of doing a little bit of research into finding out what's available around you and what's available out there. But I say, it's definitely not out of reach for anyone with access to the internet.
Are there any particular figures or people, I don't know, whether it's in popular media or people who you found quite inspiring as far as your interest in astronomy?
Um, yes. So, okay. Do you mean like personally, or do you mean from a scientific standpoint?
Any, so, it's
Okay.
open, to.
Um, so I think so to start off, I think the person who I was kind of following for the longest time, first Stephen Hawking, back when he was still alive. Yeah, I think yeah, specifically it was his movie, The Theory of Everything, that really introduced me to this field. So I'll give credit to him. Um, and then I say nowadays, or the last couple of years, I've been following well, Jocelyn Bell Burnell. Yeah, she's a very um, what's the I'm trying to think of the word in English. But yeah, I think she's an amazing role model. And especially with what she's doing with the funding she got from one of the awards, where she donated all to the Bell Burnell Scholarship, so that students from disadvantaged background can pursue.
But it's a what? They're an astrophysicist, are they?
Yes, yes. So during her PhD, she discovered the pulsar.
Oh, Bell, but I was writing it as like a as the surname. I was writing it as basically one word,
Two,
like
right?
we're starting with a V, but it's actually Jocelyn Bell Burnell. Oh, okay.
Yeah.
Irish, Northern Irish physicist. Oh, radio pulsars, 1967 Nobel Prize. Oh, right. She was not. Oh, she wasn't awarded.
Yeah.
Oh, that's a
So,
bit sad.
so she's a very interesting figure. But then yeah, I really admire her work that
Cool.
she did, and then yeah, again with the scholarship. Um, and then from a scientific standpoint, I think I've this Duncan Lorimer. He discovered he co-discovered the fast radio burst,
The
which is
fast
this
what? Sorry.
fast radio burst. Yeah,
Fast
which
radio bursts.
yes, yeah. We don't know what it is, but it's this mysterious signal we're getting from space. But it's now in the milliseconds. So yeah, it's a very interesting in transient astronomy. So I would say, yeah, personally, now I think Justin Bell Burnell is someone I really look up to. And then from a personal interest, Duncan Lorimer as another scientist. Yeah,
FRB. Transient radio wave. So the person's name is, do you say Duncan
Lorimer.
Lorimer? Okay,
Yeah,
so it's actually this part of it is named after him. The Lorimer
burst. Yeah,
bursts.
yeah.
Cool. Um, and then also, oh, physics is not an easy subject, right? For a lot of people, it's quite challenging. And for people starting a degree in physics, it can be overwhelming. It can be, especially like maybe the adjustments that they would need to make academically in the first year. They can be quite challenging. Are there any academic pointers that you'd give to first year students as far as um, really getting acclimatized to the rigor?
Yeah.
Yeah, anything in that regard.
Just ask questions. I think this is something that I failed to do, and I think I pretty much paid the price for it. But the staffs are, I mean, at least in St. Andrews, they're all so nice, and they're so keen to talk to you and get to know you, and then also share their knowledge. Like office hours, asking questions in the lecture, which yeah, another advice is if you have a question about the content, chances are your friends also have the same question, but a lot of the time people are just too nervous to ask. So I say there's absolutely no shame in asking. Um, and yeah, I think kind of um, getting over this fear of asking question or this fear of not demonstrating, but like show that you don't know something, is probably the best thing you can do for not just university, but for other facets of life. It's just, yeah, if you don't understand something, just ask.
Right, right. Cool. Um, yeah, I mean, I think we've covered a lot of things. Recently, this year you did a master's in management, right?
Hmm. Yeah.
Which is, I guess, slightly different from
Yeah,
physics,
yeah.
right? and astrophysics. What was the experience like going from doing a very STEM
Step.
heavy,
Yeah.
very, one of the most difficult really degrees. Many people would say physics is a very difficult degree, and astrophysics to doing management. Um, well, yeah, what was that experience like, and what was that whole, yeah.
It was a very steep learning curve, I would say. Um, I think anecdotally, a lot of my physics friend asked me, oh, like, which one's harder? And I think I said, oh, yeah, I think it was management for me. Because with physics, the moment you understand something, the moment with your like tutorial sheet, your homework, as long as you can do the question, like if you're able to do the question correctly, it means you understand the content and you can move on. It's very black and white. But in management, when you're assigned 3 papers to read before the next class, there's no cheat code on that, right? I mean, you can put up an AI or whatever, but like, still like you have to go through all these content. Um, Otherwise, you go to the next class and you have no idea what's going on. So there was a lot of information that I had to take in, and then with essays as well. I The longest piece of writing that I did as part of my astrophysics degree was my dissertation, which was 8,000 words. And then before that was my pre-project review, which was 2,000 words. So in total, I think in terms of like essays I wrote, um, we're looking at probably less than 20,000 words in the span of 5 years. And then all of a sudden I have to write 10,000 words per semester. Like that was such a massive shift in also the academic writing style is different from like factual to more of like a nuance, critical thinking. Yeah, that for me was a big shift. But I think I've became more comfortable. I wouldn't say that I'm now an expert on it, but like once I got through semester one was really tough because I had to relearn all these things and I put in a lot of extra effort to relearn, or not to relearn, but to learn how to do these things, which then made it easier for semester two and then for my dissertation just now.
Cool. Yeah. Um, yeah, I can imagine that's, yeah, yeah, yeah. Okay. Well, congratulations for getting through that.
Yeah, thank you.
Yeah. I don't know if there's anything else you want to add, or I mean, I've kind of, yeah.
I guess, yeah. I do want to talk a little bit about how I landed on this PhD in a completely different field, just another like things that students can take away. So my PhD would be in nanophotonics. So this is a completely, I mean, I'm still studying light, I guess, instead of light from outer space, and I was studying light right in front of me. But I got this PhD because
You said nanophotonics, right?
nanophotonics,
Nanophotonics.
yeah. Yeah. So I'll be working with solar cells and then this thing called metasurfaces, which essentially acts as a infinitely thin lens. It acts as it, right? So if you build nanoscale structures on it, you can manipulate light. And I got this PhD offer because, of D&D, Dungeons and Dragons, and 3D printing. So when I was in Boston, I decided to help my colleagues from Durham who ran the 3D printing course. It was like, for some student, they finish their 2 weeks of teaching. It's a 6-week program, and then you're in charge of 2 weeks. they finish their 2 weeks and then they just kind of sit in the back of class, help out. And I decided like, you know what, I'd be interested in 3D printing, 3D modeling, and I'll learn how to do it. So I did my best, to volunteer. I helped go and deal with a 3D printer and whatnot. And that taught me how to 3D print or understand how 3D printer work. And then me and my friends, we've been playing in this D&D campaign for like the last 4 years. And we've been designing our own characters model online, and we were thinking of ordering them. And it costs around like 20, 30 pounds per figure. And then for a party of 6 people plus the other NPC characters and monster, it adds up quite quickly. And so we went on Amazon, and then we saw like a resin printer now costs like 120 pounds. And so between me and the DM, the dungeon master, we put in around like 100 pound each, the machine plus all the resin and everything. And we just started printing our own minis and all that. And then the following summer, the PI of the group that I'm joining now, he bought a really nice 3D printer for his research, but wasn't able to get it to do what he wanted. And so the following summer, he was looking for a student who knows how to 3D print, and my friend happens to be there in the group at that time. She told me about it. The same afternoon, I went into his office. He sat me down, asked me about my experience, and I told him the story about Dungeon Dragon. And he goes, "We all have to start somewhere." Took me at his lab, and then I worked for him for 10 something weeks. Then he invited me back after I graduated last summer to come and keep working. And at the end of the summer, he said he got this European Research Council grant for a PhD student. If you're interested, just apply. And yeah, that's how I landed a PhD. I like to say because of Dungeons and Dragons.
Cool. That's a cool story.
So
Yeah,
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 I guess the moral story is like don't be afraid to try different things. There's so many opportunities out there, and you never know what's going to be the next thing that lands you the next step. So yeah.
yeah, yeah. Um, I did a bit of because part of my master's thesis involved, well, my master's project and I guess a thesis as well involved a bit of 3D printing for some light sensor stuff. It can be quite challenging to actually get what you need printed sometimes. Just basic things can go wrong. The temperature of
Hmm.
the bed, the different things
Yes.
like
Yeah.
so, and it can be a bit of a learning curve to actually learn how to do the computer aided design type of stuff.
Yeah.
It's not necessarily, yeah. I think some universities they are working on introducing more of this stuff earlier on in the degree, so that by the
Yeah.
time you actually get to the project level of or like a thesis or something, you have
Yeah.
at least a familiarity with it.
Mhm.
Yeah, cool story. Yeah. Um, okay. Yeah. Well, I mean, thanks for taking the time. I mean, it's very insightful to kind of hear a bit about what kind of that decision making process you went through, some of the things you're able to learn, and definitely it sounds like you really took the time to properly explore a lot of your interests whilst you were at doing your undergraduate studies, which is really good. I think a lot of people will find that a good example and learn from that as well. Yeah, right.
Well, thank you so much. Yeah.